Hi guys. So today what I have brought to you is a very basic level AI for a deterministic environment. This I have developed using Excel VBA, and this AI employs the concept of Bellman's theory. So it will use the Bellman's equation to find its target, uh, whatever we give to it. And before I jump into the into the demonstration of how the AI works, let me quickly give you a basic of what this interface is for. So if you see this run AI, this is simply to trigger the AI. So once I click this, the AI will start finding the path of its goal in the grid. Show path is nothing but once the AI has finally find that path, show path will reveal that path. Hide path is simply hide it so that we can show it again maybe if we want. Reset will reset the grid and make the AI to forget everything, and then we will have to maybe again start from beginning for the AI to again find the path. And make grid is, so you can see I have already 4 grids in this page which we will be trying in this session, and then finally we will try one more additional grid. So this is only to demonstrate you that you can create your own grid with different hurdles, different goals, different fail objects, and AI will still be able to find that, work within that grid and find the path. And once we run it, you will find that you will certainly find places where you will realize that the AI can be certainly further optimized. That's true. I have optimized it, to a certain level, but yes, there's still opportunity of optimization, which even I am working on. So that's it. So I will just begin with the very first grid. So let me just set this grid because currently the AI. So I'm saying the with this step that I just did, I'm saying the AI that you are supposed to play on this grid, and your start position will be this. And what you see here is these gray things are the walls, and these white places are the steps that the AI can take. AI can move around all the white spaces. The reds are failure, so if the AI steps onto this red, it will fail. And the green box is the actual goal that AI needs to reach to. So once I trigger this, you will see how AI starts to find the path, and it may fail a few times. Ultimately it finds the path to the goal or not. So I will, and this which I forgot, this AI speed that you see here with this scroller is basically how fast we want our AI to go. And since this is a smaller grid, I will increase the speed to maybe like 50. That should be good. But for bigger grids, where the AI has more steps, possible steps, we will reduce that to 0 so that we can, pass through the entire demonstration quickly. So I have set the speed to 50, and then we have given this grid for the AI to work, and we will see once I run it how it works. So I'm just going to click on this run AI, and you see. So now you see, oh, so you might have noticed that the AI started going through it, and it finally, hit that red object and it failed. So it's saying, okay, so it first thought it has reached, but it very soon realized that it's not the goal, and it finally realized it has failed. So what it will do once I say, okay, it will quickly start again. So this will be, now it will be the second gen AI. So now it will start again and try to find, okay, it failed again. I'll say okay again. It will take a few steps, few chances to finally reach. Okay, so it failed for the third time. But now since it has already failed 3 times and there are only 3 possible failures, the AI should not be failing anymore, because now it knows what what happens if it takes a certain step. So it has already identified the failure things, and it will not fail anymore. So okay, so finally you see the AI is saying it knows the path. So we'll say okay, and we'll say show path, and you see it will find the the most optimized path it could. I know it can be further, optimized somehow, but yes, currently this is what we have. So now let's test this with another grid. So I'm just going to give it this grid this time. So I'll click on make grid, set grid, and I will say this is my new grid. Okay, and I'm going to tell it what is the start position. So let's give this, or maybe this time this one to be its start position. Okay, and now let's just do a reset once, and now we will do the, and since this is a bigger grid, I'm going to reduce these, I'm going to increase the speed. So the down this number is, the faster the AI will move. So I'll just let me just make it 0 and click on run AI. Oh, it already reached to that portion. The AI is really fast. So, and it failed once, it failed twice. Maybe I should have failed thrice, failed for the fourth time. And let me actually increase, yeah. So I have, reduce the speed that the AI is executing at, so that we can actually see what it is doing. Oh, so it finally has found the path. And if I say okay, now if you say show path, see here what it finally found. So it could finally, find the path to the goal, right? So if I hide path and if I say show path again, it will show you. Now let's try it with more open world. Here we have no walls, we only have two fields and the goal, and let's see how it works on this grid. Say okay, and let's give a start position of maybe this, and say okay, and I'll say run AI. So it has started to explore the entire world. Okay, so it failed once. Oh, it failed twice. In ideal scenario, it should not fail more than that, because it already knows which area if it goes, and once it has reached there, what action it will take, the action which will actually make it fail. So it will not do that mistake again. So this is how the AI realizes with experience what makes it fail, and it can, next time it can use that experience of itself to ensure that it does not fails again. So let's give some our AI a little more time. So let's try to increase the speed by reducing this number. So I'm just going to make it 5. That should be good. And as maybe you can again realize here, that this AI can be further optimized, which I'm currently working on. So maybe I'll reduce the, okay, so it finally found the path, and let's see. Oh, okay. So it took this path to reach the goal. However, it could have taken a very straight path as well. As I said, we can have it more optimized, but it finally found this path to its goal. Next time, if we run the AI again, it will maybe find this path to the goal, or third time it will pick this path to the goal, but that's how it is for now. So now let's try one more last example of, of the given grid, and then we will try one new grid. In this world, the difference is what I have created is there's no wall, it's all the open world. Everywhere the AI can move. However, there are fails. So in all of these grids, you might have seen that there are walls where the AI do the action cannot be taken. These AI cannot take a step on them. So it's anyways, these walls are kind of guiding the AI. But in this world, we have only created failures and have not created any wall that will be guiding the AI. So AI will have to learn how, in what all steps that makes it fail, and then it will finally reach to the goal. So this is what I wanted to demonstrate here. So I will set this grid this time and say okay, and let me give a starting position here. and I'll say reset, and I'll say run. So, oh, okay, it failed already. I'll say okay. It failed again. I'll say okay. Failed again. I'll say okay. Failed again on this step again. So I'll say okay. Okay, it reached here. It failed. I'll say okay. Okay, it failed here. It passed through all these steps, and then maybe you took this path and failed here. I'll say okay. Okay, it failed there. Okay, it failed there again. Okay, and it failed here again. Okay, then again failed, again, 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 again. However, you might notice that it will never repeat its previous failure. So it's failing, but as you can see, it's reaching very close to its goal. So far it has, oh, it knows the path now. So if I say show path, you see it how it, from, so let's increase, reduce the speed of the AI. So let's make it 100, hide path, and let's see how it will. You see, this is how the AI could finally find the path. And you might think that these grids are already made, and maybe the code is made in such a way that it will ultimately find. To demonstrate that thing, let me create a new grid. In this example, I'm not going to create a big grid, so I'm just going to create a smaller grid, a dummy grid, and say okay. And let me place a few walls, so maybe this and this, and I'll say okay, and let's place a few fails. Okay, so let's give this the fail area, and maybe this the fail area, and now let's place a goal. We can have multiple goals as well, so let's give two goals this time, and any of it, if the AI reaches any of it, we will consider it to be start, it success. And now let's maybe give the place of this to be the starting place, and say okay. And now since we are ready with it, let's run the AI, and let's this time again, I want to reduce the speed a little, so let's make it 20, should be good, I guess. If not, then so it failed already once. Okay. Oh, it failed again, failed again, failed again, again, and here again, here again. Okay, it finally found the path. Now if I say, let me actually increase the, this delay thing, and I'll say show path, let's see. Okay, it reached to that goal. So it took a smaller path and found the closest goal, and it went there directly. So as you can see, so it took, so it's not like something is already coded, it's only the AI. So even if you create your own grid, create a very different goal, and create a very different, what you say, maze of failures and walls, it will still be able to finally, after failing multiple times, it will still be able to finally reach its goal. And yeah, the thing you already saw. In the next version, which I am currently working on, we will maybe have more complex scenario where maybe the goal is not stable, it's continuously moving, and we will see how the AI will still be able to, target and find the moving goal, or maybe we'll also have the failure things continuously moving, so that it can identify and still navigate past those, non-stable and continuously moving failures or continuously moving walls. So that we will, see in the next version, which I'm working on. That will be a bigger, more complex AI. So this is it for this, for this video. Do let me know if you like this. Do let me know if you have any questions on it, and yeah. So that's it. Thank you so much, guys, for watching this. Thank you. Bye.